and welcome to your very first Algebra 2 prep lesson/video. There are a few topics that we always wish we had time to prepare you for in Algebra 2 because we know, having taught Algebra 2 before, that these are sort of the foundation topics or things you really should know like the back of your hand before you take Algebra 2. And it just so happens it took a global pandemic, but we now don't have a Regents in geometry and we have a little bit of time to get you ready for this. So it's super, super important because Algebra 2 is that tricky year that can trip you up if you're not going to stay on pace with everybody. So look what I have here. I want you to write this down. We're going to take all our notes on blank paper. And what I have here is 2x squared plus 3x plus 9. And you'll notice that there's an x squared family, we'll call it, a regular x family, and then a family without any x's. And they're separated by pluses. They could be separated by minuses or equals, but when we count the number of terms, so you want to jot that down, the number of terms, you separate them by plus, minus, or equals. So this is a term, then there's a plus sign. This is a term, then there's another plus sign. That is a term. So there are 3 terms. The next idea is evaluating. So write down this, evaluate, and I just chose x equals -4. So what that really means in slang terms is plug in. Evaluate, really, we sometimes accidentally say plug in. So take that -4 and plug it in where x was. So it was 2x squared plus 3x plus 9. And when we evaluate that for the number -4, what we're really doing is putting a -4 in parentheses everywhere an x used to be. So we're going to type this into a calculator. You do it by hand, I'm going to show you on a calculator how that would look. So we're going to go, so we have 2x squared plus 3x plus 9. And where the x's were, I put a -4. So when I evaluate that expression for -4, I get 29. So I can say that this would be 29. The next piece asks us to add, so doing like an operation, we're going to add this to this, so 2 trinomials added together. So go ahead and write this plus this. And really what we're doing is combining like terms. So you can see I have something from the x squared family added to something with the x squared family. So if I have 2x squareds and you have 4x squareds, together we have 6x squareds. Then I have a regular x family. I have a positive 3x here, minus 12x there. So it's 3 x's above 0, and then 12 x's below 0. That's going to be a -9x. And then I have the regular number family. We call those constants. So I have a positive 9 and a positive 1, which combines to be a positive 10. So this is my added version of those 2 trinomials. I combined like terms. Okay, so real quick review of terms. How many terms does this one have? This first one, 3x squared minus 4. Terms are separated by pluses, minuses, or equals. So this is a term, then there's a minus sign, and then that's a term. So there are 2 terms there. This one has a term, then there's a plus, then there's something else, then there's a minus, then there's something else, then there's a plus, then there's something else. So this one is a polynomial of 4 terms. And then as crazy as the third one is, it's still just 3 terms, because you have 1 there, and then a minus sign. And because there's no pluses or minuses in here, that's all one chunk, one term. Then you have the plus sign, and then you have the third term here. So there you have a 3-term polynomial, which is also called a trinomial. So let's practice just simplifying and combining like terms. So write these down one at a time. I'll leave that one up there so you can see it. 2x squared plus 8x minus 1 plus 3x squared minus 6x minus 7. This has got 6 terms, it looks like. But we want to combine things that can be combined, things from the same family. So I'll do it with a highlighter this time. Here we have something from the x squared family, and I found something else from the x squared family. So those two can be combined. If I have 2x squareds and you have 3x squareds, we combine those up and we now have 5 of those things called x squareds. Okay, then I have something of the regular x family, and I found something else from the regular x family. So these two can be combined. But now always include that sign with it so you know whether to go up or down. So I have positive 8x's minus 6x's. That leaves me up 2. 8 minus 6 is positive 2x. And then I have the regular number family. Negative 1 below 0, and it goes down 7 more degrees. Now it's really cold. Going down 7 more, and now I'm at negative 8 degrees. So that is a simplified version of what's above it, because I combined things that could be combined. So let's try to jot down the next one. Negative 5x squared minus 3x plus 11 minus x squared plus 4x plus 3. The x squared family, the x squared family. If I'm down 5 and I go down 1 more, what happened there? I'm at down 6x squared. If I'm down 3x's, but then I go up 4, that puts me at positive 1x, negative 3 plus 4 from the x family. And then I have 11 plus 3, which is 14. Okay? And this last one can get a little confusing because it almost plays tricks on your eyes. Here I have an x squared y family. So we're looking for somebody else from the x squared y family. They all sort of look like that, but the only one that really has x squared y is that one. It's a weird sounding thing, x squared y, but if I have 4 of them and I take away 1 of them, I now only have 3 of those things called x squared y's. Then we have another family, the xy squared family. The squares of the y. So the x squared y family, and here's another x squared y family. If I was down 3 and then I went up 9, that puts me at positive 6 of those things. What things? X, y squareds. So you're just combining like terms. That leads us from expressions into equations. So an equation, you'll notice, has an equal sign. You're solving for something. See the equal signs? Whereas what we were doing before, these are just expressions because they don't have equal signs. You can't solve them. They're just combined or have to be evaluated later. Now we're going to actually solve these. So let's write down our first example. 6x plus 10 equals 52. I honestly still do this when I solve equations. I find the equal sign, and I draw myself like a little fence, I call it, like I want to know what the left and the right side are. I don't write the L and the R, but I always want to visualize this as this is one side and this is the other side. Because when they get bigger like this, it's easier to miss where that equal sign is. So the first thing we do is we want to get x alone. So the very first thing I do is subtract the constant from both sides. Because what that's going to do is leave me with just 6x over on the left side and 42 on the right side. So it's like backwards PEMDAS. I want to get x alone. What's happening to x? It's being multiplied by 6. The opposite operation of multiplying is divide. But whatever you do to one side, you have to do to the other. 6 over 6 cancels to 1, and 42 over 6 is 7. Not that bad. Now here's one that has x's on both sides of the equation. 8x minus 7 equals 4x minus 5. And I'm still going to do this. So I have a left and a right. It doesn't really matter which one you do first here. I like to get rid of my x's first on one side, or move all the x's over here and move all the numbers over here. So I'm going to take away 4x, but whatever you do to one side, you have to do to the other. Now notice I couldn't put 4x under here, because those are not like terms. So the reason we learn combining like terms is because they have to be put together. That cancels out to 0. Subtracting 8 minus 4x is 4x. And minus 7 is still there. Now I'm down to a problem like I had before. Now I'm going to add 7 to both sides. This is the opposite of subtraction. That cancels, and I have 4x equals positive 2. When I divide both sides by 4, looks like I'm going to have a fraction here. I have x equals 2/4, which can reduce to 1/2. Now this third one has a fraction involved. So the first thing I do after I identify my equal sign, I want to get rid of this 3. It's being divided by 3, so I multiply by 3, because what that's going to do is allow me to cancel 3 over 3. So whatever I do to one side, I have to do to the other. So I'm multiplying both sides by 3. I only had x plus 4 remaining over there, and negative 15 now on that side. And now it's pretty simple. You just take away the 4 to get x alone. Negative 15 minus 4 is negative 19. I want to pause and jot this one down. I'm going to draw the left and the right, because I'm going to move forward now. I'm going to distribute to get rid of the parentheses. I'm going to distribute the 6, and I'm going to distribute the negative 2. And that's going to look like this. 6 times x, and then 6 times 4. So 6x plus 24. Negative 2 times x, and then negative 2 times negative 1 is positive 2. And I just rewrote the other side. Now you're going to combine like terms over here. 6x, take away the 2x from the same family, gives you 4x. And then I have 24 plus 2, which is a 26. And then over here I still have a 2x plus 20. Now I can slide that over there and make it look like it's all together. And now it's just a two-step equation from there, where I'm going to take away 2x from both sides. And that leaves me with that. Then I'm going to subtract 26 from both sides. And that leaves me with that. And then when I divide by 2, I am done, and my answer is negative 3. So that's a really good model to look at, because now what you're going to do without our help is try these 3. So the video is going to ask you for an answer to 1, 2, and 3. You're going to write these down, and you're going to pick the multiple choice answers for 1, 2, and 3. And we are here for help tomorrow. Good luck.